Last week when we introduced NumPy, we dealt with a lot of numbers. This week we'll visualize these numbers, or data in general, using Matplotlib. Matplotlib is a library for producing publication quality figures, while also enabling interactive cross-platform control over how we plot our data and with what appearance. So if someone else has access to our data and code, they can highlight different aspects of the data and also change the appearance to their liking. Now for us, as we're learning Matplotlib, the most central question will be, how can I make a figure that plots x against y in a certain style and has these features? And while Google is very competent, that kind of search question will probably not yield any results. And so that's why we can go to matplotlib.org and check out their gallery. In this gallery we find a lot of examples that we can click on to check out the code. And so we can scroll through these examples until we find something that matches our needs. Or maybe we find interesting features that we want to incorporate into our own plot. So maybe we're interested how to add these statistical distributions to either side, and maybe we want to combine it with this kind of scatter plot. So we can check out the respective codes and then just combine them. Okay, but now starting with the basics, what even is a plot? When we talk about plots, we could say that we refer to the figure object of Matplotlib. And this figure object is the top level container, which can contain multiple subplots, also called axes. And these axes, or subplots, each then have a x-axis and a y-axis. Okay, so let's create our own plot or figure. For that, we first import the Plt submodule from the Matplotlib library, and we import it with the alias Plt, so that we don't have to write pyplot every time. And now with this Plt submodule, we can create figures, calling plt.figure. But this line alone doesn't do anything. Even if we explicitly type the figure, we're not getting any output. It just says figure size with 0 axis. And that's because notebooks will not show empty figures. So if we were to run that code in a normal Python script in our editor, and then if we would call plt.show, then it would actually show us an empty figure. So it would look something like that here. Okay, so our figure is empty, so let's add some stuff to it, namely axes or subplots. And all plotting that we'll do later will also happen on these axes or subplots. And they always have to belong to a figure. And so to set up a figure with some axes, we have two options. The first option is calling, like we did before, plt.figure, which gives us a figure, and then on this figure we can add a subplot. And the argument that we pass to this add subplot function may at first be a bit confusing, because you might be thinking, what does this 111 stand for? But it's actually not 111, it's 111. And it indicates that in a 1 by 1 grid of subplots, we place the subplot in the first slot. So if we instead write 2, 4 and then something, that would mean we have a 2 by 4 subplot grid, and then in this grid we, in this line, add a subplot to the first slot, then here to the 4th, here to the 6th slot, and here to the last one. And arguably this syntax isn't very convenient, especially if you want to create multiple subplots. So let's move on to the second, in my opinion, better option for creating figures together with axes. And so for the second option we call plt.subplots, and to it we pass an n-rows argument and an n-columns argument. And the values that we pass to these arguments here also correspond to a grid that will be created. So right now our grid has just one row and just one column, but we can also have a figure with multiple axes. So here we pass 2 and 4, and that gives us a figure with 2 by 4 axes. And right now our figure looks very crowded, so the axis tick labels are overlapping and the figure is also kind of small. So to solve that issue, we can first call fig.tidyLayout, which makes sure that none of the labels are overlapping, and then we can also pass to the plt.subplots a fig size argument. And there we specify the width and height of our figure. So now its size is 10 by 4. Okay, we're almost done creating the scaffold of our figure. What we're missing is axis labels and titles. And so for that, let's switch again to just a single subplot. So we set n-rows and n-columns equal to 1. And the subplots function returns us the figure in axis. And so now to add axis labels and titles to this axis object here, we make use of its methods. And so for example, we can use x.setTitle to set a title. We pass the string an example axis, and that's now our title. We can also change the axis labels for y and x, and also the axis ticks. So on the x-axis we go from 0.5 to 4.5, and on the y-axis we go from -2 to 8. And if we want to show our figure in a notebook, we can do that by writing the variable that it's assigned to. So we created the figure with the Plt.Subplots that assigned the figure to this figure variable, and then we simply called it here. Looking at these methods calls here, we noticed that they are quite repetitive. So we have to write set every time, and also our access variable. And like we're used to at this point, if something is repetitive, there's usually a shorter way of doing it. So what we do instead is that we call the set method on our access object. And to the set function, we pass the different setters as keyword arguments together with the values. So instead of writing, for example, x.setFoo with the string bar, we can instead simply write x.set and then give the foo as a keyword argument. And this achieves the same thing. Okay, so now we have a proper figure, but we're missing, of course, our data. So how can we plot data? And most of the plotting occurs on the axis. So to plot something, we have to make use of the axis methods. And we'll have a big section on the plotting methods, but for now, we'll just have a look at the plot and scatter. Plot will simply draw points with lines connecting them. So in this code cell here, we call the Plt Subplots with n rows 1 and columns 1. So that will give us a figure object which has one subplot or one axis attached. And on this axis or subplot, we then call the .plot and pass it first the x coordinates and then the y coordinates of our points. And so it will then draw these points and connect them with lines. So the first point sits on x equals 1 and y equals 10. Then the second point is 2 and 20, so 2 and 20, and then it will connect these points. We can do the same thing for scatter. So instead of calling x.plot, we simply call x.scatter, and this will also draw points, but it will not connect them. We can also have multiple calls to the different plotting functions, and this will result in overlapping plots. So we start in here, we create our figure and axis, we plot a scatter plot, and then here we plot a simple line plot, and this gives us this figure here. Okay, next step, multiple axes. We already created figures that had multiple axes, or subplots. So here again, we're calling the Plt.Subplots, giving as arguments n rows equals 2 and n columns equals 2. So we have this 2 by 2 grid. And now instead of having a single axis object like we had when we called the Plt.Subplots with just 1, 1, we have a whole array of axis objects. And it's also a convention to, if we have just one axis object, to write ax, and if we have multiple, we write axis. Okay, so we have our axis in an array, and we can index this array to access one of the subplots. And once we index one of them, we can then also plot on them. So we can, for example, write axis, then indexing at 0, 0, and then we plot these points here. And that gives us then this line plot here. Of course, we can also index the subplot 0, 1, and then draw a line on the top right subplot. If we have multiple subplots, then titles can be especially useful. And so the same as we call the .plot on the individual subplots, we can also call the .set. And so on the top left plot, we set a title with the string upper left, which gives us then the title upper left for that subplot. Sometimes it can also be useful to have a supertitle, and that can be created by calling the figure.subtitle. And again, we pass a string, which is then our supertitle. Okay, that's it for the basic structure of Matplotlib. On a final note, there's also a different syntax that we can use if we want to do some very quick plotting. And this is done by calling the plot not on an axis object, but on the Plt submodule. And while this code looks much cleaner and simpler, we only have one subplot to play with, and even if we have multiple separate subplots, it's very difficult to keep track of which axis is current. So if we have another axis object somewhere in our script, then it's hard to tell which axis the Plt.plot will draw on. And so that's why the syntax that we established before is very convenient if we're working on a slightly bigger project. Okay, quick rundown. First, we import from Matplotlib the Plt submodule, and we call it Plt. From this Plt submodule, we can call the Subplots function. We give it a number of rows and a number of columns, and also optionally a figure size, and that returns us then a figure, which is the container of all the axes. And the axes come in form of a numpy array that has a shape according to the rows and columns that we specified. So here's 2 by 2. We can then index this array of axis objects to get a single axis object, and on this single axis object we can do plotting. So we call .plot, which gives us a line plot, or we could call .scatter or any other plotting function. Besides these plotting functions, the axis objects also has setters, which we can use, for example, to set a title or customize the X and Y axis.